3.5, day 1, part 4. This formula slide, don't write it down. You already have it in your notes. Reviewing compound interest, there's 2 formulas that we had you write down in your notes along with these pieces. If you talk compounded monthly, daily, yearly, quarterly, we're going to use this left formula right here. That one look familiar? And the one on the right, we only use the one on the right when it says compounds continuously. We refer to that as the PERT. So then the A is your end amount, your P is your initial amount, your R is your interest rate in decimal form, your N is the compounds per year, and then the T is time in years. So those 2 formulas we're going to use on the next slides. So the students last hour said they know how to do these first 2 questions because we've done them already in the class. So I'm going to check with you if you're okay, we'll skip it. $12,000 is our initial investment at 9%, and we want to find out what is the value after 5 years if it's compounded quarterly or continuously. Do you remember how to do those 2 problems? So you're just substituting in. They were kind of like what those questions were on the quiz. Okay, so we'll skip it. We'll go on to the new question. I would recommend you write this example down. This will be our last example in the lesson today. So let's say we have an account, a savings account, and the bank says that you get 6.75% interest, and it's compounded continuously. And we want to find out how many years will it take for this account to double in size and triple in size. So I have the formula already written down for you. Why do we know it's that formula? Because it's continuously, compounding continuously. You can also do the same question if it's compounded monthly or yearly or daily. You just have to choose the other formula on that slide 2 ago. So I'm just going to do one of these, and then if you want to choose to do the other one, the part B, you can do so. It's pretty straightforward. So do we know how much money is in our savings account? No, and we really don't care. So just make up a number. And the easiest number is $1. We go into the bank and we say, we have $1. And we want to find out how long it will take for my dollar to double to $2. How many years will it take? So in my equation, where is those numbers going to go? So I'll say, let P equal $1. So then A must equal $2. It'll work for any amount of money. What is the other thing I'm going to plug in? R. And what will be the R?
0.06.
Good, 0.0675. So convert it to a decimal. So now let's substitute in. So what will be the left side? 2. What will be the right side?
1e to 0.0675.
Good. And now we take that exponential equation and we solve it for what variable?
T.
T. So think back to our section that we just did, 3.4. How do we solve that equation? What do we move first? Divide by 1. So we get 2 equals E raised to the 0.0675 T. What's the next step to solve for T?
Natural log.
Natural log. Take the inverse of the exponential E, natural log both sides. And then I'll be left with the natural log of 2 on the left. The natural log and the E will cancel out. And I have 0.0675 T. What's the last step? Divide by that decimal. The natural log of 2 divided by 0.0675 equals the time. And then you would enter that into your calculator. Approximately how many years will it take for my money to double? You get about 10 years? 10.3 years, about. Now, part B just says it's going to triple. What would be the only difference there in that problem? Put a 3 instead of a 2. So we have one problem to finish in the lesson. I will show you what the homework is because you're going to want to get started on it. And I just grouped it into 3 kind of style categories. They're all in the same section. They're all in the same pages. 7 through 15 odd. And then I want you to just do 17 A and D. Then on page 244, 25 through 29 odd. And I gave you the formula. Does that formula look familiar? Yes, that's the formula we use with radioactive the decay problems. And then 35 through 42, do all of them, but skip number 36. It is a lengthy assignment. We are really focusing on, do you know how to do application problems? We're getting into the IB way because you will have lots of application problems on this next test.